Hello and welcome to a new episode of Agile TD Mondays. This time with Alex Schladebeck, who is a frequent speaker at conferences such as the Agile Testing Days. Please save the date for our 9th edition of Agile TD from the 13th to the 17th of November in Potsdam. And now to you, Alex.
Hi everyone, and welcome to my webinar on how to stop hating UI tests. Thanks for introducing me, Sabina. I'm really happy to be here, and I hope that I'll be able to share some interesting and helpful things with you to make sure that you all stop hating your UI tests, because I know that a lot of people really do. Okay, short introductions for anybody that doesn't know me. I'm a tester. I'm head of testing at the company Bredex that I work for. We are a software development company based in Braunschweig in Germany. And I am super passionate about quality. My aim in life is to get people to invest more in quality, to love their tests more, to love their testers more. And that's one of the things that I work on here with my team. What the company does that I work for, we do software development. We do have quite a strong focus on quality. We have an open source tool that we develop called Jubular. And we also have a multi-tool strategy. We use a lot of Selenium, and a lot of the examples I'll be showing today are from Selenium as well. And one of our main focuses in terms of test automation is making that scalable. And that's some of the things that I'm going to be talking about today, about UI testing as well. So the journey that we're going to go on, I want to take you through 3 steps. The first step is I want to look at some of the reasons why people hate UI testing. Then I want to look at some test structure for scalable UI tests to see how we should be doing it to maybe not hate it quite so much. And then I'm going to give you quite a few examples so that you can see some bad examples and some good examples of what this level of tests should look like. Before I begin, I'm going to have a very, very short rant because a lot of the things that get said about UI testing really aren't true or aren't fair or aren't true anymore. So give me a couple of minutes, give me a couple of slides to let all of my anger and frustration about the state of the union out. Okay. So people tend to say about UI tests, they give us such slow feedback. These are things that we hear from people when they're talking about it. UI tests need so much more infrastructure if we're automating them. We need virtual machines, we need logins, we need all of these kind of things. Then there's the problem that they're at the top of the pyramid. They're practically unimportant because they're right at the top. They're flaky. This is another thing that people say a lot. And also that small changes can lead to a big work to doing a lot of changes in the UI tests so that we end up having to say, okay, we're going to throw away our automated suites and rewrite things. Now I want to look at a couple of these things just from my perspective and from my experience. So let's have a look at the slow feedback. Well, yes, but it's a different level of feedback. These are things that we can usually wait for. It's not usually the case that our automated UI tests are the things that we need to run after every single commit. There are different types of tests and different levels of tests for that. So yes, the feedback is slower, but it's okay that it's slower. We can wait for it to be maybe every day or every night, depending on how you're running your tests. More infrastructure. Well, the easy answer to that is yes. Yes, we do need some more infrastructure. If I'm being slightly sarcastic, then I will say if you want nice things, sometimes you have to put nice things in place for them. That's just a fact of life, but with things like virtualization and even containerization now, that's not the hardest thing to do, and it's worth doing. They're at the top of the pyramid. This is one of my favorite things. Yes, they are indeed at the top of the pyramid, but they're still in there. They are still there, and I agree that there are a lot of contexts where this idea of doing as many unit tests as I can, or unit tests at the right level, API tests for the right levels, and UI tests for the right levels, that's a very, very good point. Just because they're at the top of that model doesn't mean that the user focus isn't valid. In fact, if you ask me, user focus is incredibly valid in a lot of contexts, and context really is a very important point there, because it might not be the case that the pyramid is exactly the same shape for every given context. The point is to use your UI tests to do things that you need and should do via the UI, not for other things, and to use unit tests, for example, for things that you should do via the unit level. They're still in there, and you need to consider your context. They're flaky. Well, one of the one of the things is, yes, sometimes they can be. I mean, the tools that we're using, they are written by people in the same way that every other piece of software is written by people. Nevertheless, UI testing tools really have achieved a certain degree of maturity over the last 10 years, for example. Most of the flakiness now that I see in projects usually becomes because the tests are badly designed, or they're being used for the wrong type of things. They're being used to test the wrong type of things. Or, for example, because I haven't done anything about test data management, and for every single small test case, I have to click all the way through the application. So yes, they can be flaky, but that's not usually because of the tools. It's usually because the tests themselves have been written badly. Small changes lead to big work. And here, there are two things that I'd like to go into. The first thing is that can be the same for development too. I mean, if a customer decides that they want to change something, then depending on how we've modeled that, or how the architecture is, or how the feature looks right now, it can be the case that the development work for that can be quite a lot. So this is just something that we have to accept on some level, sometimes. And the second point is, which is probably the most valid in the context of UI tests and automated UI tests, usually only if you design them badly. This is the bad smell, that if small changes lead to big work, then you've probably made some mistakes designing your tests. So to boil it down to 2 points, we often use tests, UI tests, to test things that shouldn't be tested via the UI. I have lost count of how many conversations I've been in where some kind of acceptance criteria or validation or various things that I really want to say that should be a unit test or that should be an API test, that just because we have a UI testing tool that we're using, that everybody wants to automate it via the UI. So one thing that we can do is to stop automating things that shouldn't be automated via the UI. That will help us quite a lot. And the other problem is that a lot of these things come from them being written badly and structured badly. And that's not just by developers, and it's not just by testers. So you can see Batman slapping Robin. I get very upset anytime that people are talking about capture replay. I even have a slide about that in just a second. This really is my passion. Doing testing via the UI is one of my great passions, and it makes me very, very sad when people just think that it can be reduced to recording something and then that'll be fine. So sometimes testers might structure UI tests badly, maybe because they haven't had any training in how to structure them. They do have the user perspective, which is incredibly important, but maybe they need some training in structure. And developers, if they're writing UI tests, they probably will use different structures that might not necessarily be valid, and they are sometimes missing the user perspective. So they will tend to write very, very, very technical tests for something that might not necessarily need to be so technical, because we need the user perspective. So I hope that testers and developers will learn something today. Okay, so rant over. That was the short version of the rant. Feel free to find me at Agile Testing Days for me to give you the long version of the rant. I'm very, very, very happy to do that. To be entirely fair, it's not really the fault of the testing tools themselves. It doesn't matter which tool you take. If you take Jubular, if you take Selenium, if you take Appium, if you take any UI testing tool, the only thing that that tool is thinking of is how can I address the components in an application. So if you look at the contact manager that I've got on the screen right now, any tool looking at that first component will probably be thinking, oh, what is that? Is that a list? That appears to be a list. What can I do with lists? Can I select something? Can I check something? That is all that they are interested in. And I know this from the experience of being involved in writing a UI testing tool as well. That is really what we're interested in, being able to address components. They give you absolutely no structural support for your test design. That is not part of their job. What they can often do is help you to make a mess, because a lot of tools offer the dreaded capture replay mode. And I'm even going to quote myself now, something that I've been saying since I started, since about 2006. Capture replay is the devil's work. It is what gets us into all kind of sticky situations. It gets us into the feeling that we have a set of tests very quickly that we are never going to be able to maintain. It gives us the feeling that we don't need to think about any good practices for writing tests. It's absolutely awful. Put capture replay and copy and paste on your list of things never ever to do. And if that works, then you will have all taken away something from this webinar that is going to help you for the rest of your life. Okay. Because what usually happens, most especially if we use capture replay, but actually sometimes if we're just writing tests manually, we have a tool API. So that can be Selenium, that can be Appium, that can be any tool that you're using, and that tool has some kind of interface to be able to reach this addressation of technical components. And right at the top, we have some kind of test case that we want to execute. Like, for example, I want to automate that I create a customer. And what we tend to do, definitely with capture replay, but also when we write tests manually, is just to do direct API calls from the tool to create the workflow. So if I need to input some text, click, and then do a check, then I call those things directly from the API. This is going to, over time, give me a great deal of redundancies. It becomes practically unreadable, if not completely unreadable. The focus is entirely technical. I'm going to end up doing a lot of technical stuff at a level when I actually want to be looking at the tests in terms of what is this doing, what is the user, or what would the user be trying to do right now. It's also not conducive to teamwork, because if somebody else needs these 3 steps, then they're probably going to copy and paste them, or they'll just do them themselves, or they won't know that they even exist. And then suddenly, very quickly, we have a horrible, horrible mess of spaghetti code, and everyone says that UI tests don't work. And then we're back at the rant again. Okay, so if we want to look at how tests should be structured, we still have our tool that offers us some kind of API, and we still have test cases like, for example, create customer. If I go from the top down, then the next level below a test case is something that we call functional workflows. The idea being that if I want to create a customer, then the workflow to do that is, well, in this case, it's going to be probably create customer, and that will consist, we'll see in an example in just a second, of things like opening the dialog, actually filling in the details and clicking OK. So that would be a workflow. Each workflow consists of multiple functional atomic actions. And the idea of an atomic action is that is one interaction with one UI component. Now, usually that is actually one action. So depending on the tool you're using, that will be to enter text into a component, or it will be to click a button, and it will be to click a specific button. So for example, clicking OK on the login screen. Some things might involve a couple of actions. We'll see some examples of those later, but the idea is that this is one logical interaction with the user interface that we're doing. Of course, there is a technical level, because from the tool API, I might want to have some exciting and useful technical keywords to do synchronization, or if I have some complex components like tables, I might be able to want to search through the table based on a column and a value that I want from that column. So there are going to be technical things as well that I want to reuse throughout my tests, but they should be in their own separate layer. Now, the functional, we'll see this in just a second, the functional workflows might end up being split into private things that are more internal. We don't want to reuse those directly in test cases, and public services. And of course, this is quite close to the page object pattern, which I will get to in just a second. The great thing about starting to structure tests like this is that if we're looking at multiple people and teams being involved and interested in tests, which I think is a great idea, not just in Agile where we talk about whole team quality, but in any project, it makes sense that the test manager or the customer can say, hey, this test case failed. What happened? Maybe look at the workflow level and say, I couldn't create the customer. Okay, what happened? Go and speak to somebody. Somebody who's looking at tests from a more functional or user-based perspective is going to be able to write and understand functional workflows, functional atomic actions, because these are things that the user will do as well. Click OK, create a customer, do a login. These are very, very logical things to look at. Then as the lower we get in the levels, then depending again on the tool that you're using, that might need a bit more technical know-how or programming knowledge. You might have some more technical testers working on that. You might even have some developers writing these keywords, figuring out how to make the tool API play with your application in a sensible way. And of course, every project is going to be different. We have projects where we just have a functional tester and that person does the whole stack. We have projects where it's split. We have projects where we have technical testers that do the whole stack. The point is that everybody has a good level, and anyone coming into the project is going to be able to work with these levels to find out what's going on and find out where things are and when things need to be maintained just in one place. So let's have a look at an example. I think I wanted a bad example first. No, this is the example I wanted to see. Okay, so having a look at some of those levels that we just talked about. So a technical keyword might be something like replacing a text. Now, again, depending on which tool you have, that might be something the tool offers from its API, or you might have to write that yourself, for example, by clicking, selecting all, and then sending some key presses. And you don't want to have that rewritten every single time you want to replace text. That's going to happen a lot in UI testing. So you write yourself a nice technical keyword. That gets reused in a lot of places, for example, in functional atomic actions, like if we're sticking with our customer example, to enter the customer name. So the customer name will be a replace text. Entering the customer name gets reused in an internal workflow to fill out that customer form. So this is just a small example. Obviously, customer forms are probably a bit bigger, but we have 3 functional atomic actions reused in there: entering the name, entering the address, and entering the postcode. Now, this is still something that's internal. We don't want to reuse it in a test case directly, because what we actually want to reuse, for example, is to create the new customer, which involves opening the dialog, filling out the form, and then clicking save. The reason that we split these things is because I might want to fill out the customer form and click cancel. So it makes very, very little sense to completely encapsulate that save in the internal workflow, because I probably won't need that all of the time. That service, that public workflow, then gets used in a test case. That is, for example, to create the customer, where I check that the customer doesn't exist, create the customer, and then check that it does exist. And why we do that, I will get to in just a second, because that's also a very important pattern for writing tests that are at the UI level. Okay. Based on these workflows and actions, then we can start splitting the application into functional contexts. So I've been talking about dealing with customers. That could be one context. There could also be the context of master data. There could be the context of the admin area. The idea of this is that splitting the application into logical and functional units, first of all, means that you know where to find things. It also means that if you have multiple testers or multiple people working on a project, that it's easier for them to be working on a separate part themselves, so that they're not always dealing with everything else that everybody else is writing as well. So we split that into contexts. So every a context will consist of the workflows and the actions to deal with a certain area of the application. Now, for some of you, this might sound quite similar to other things. So it is quite similar to the page object pattern, which separates services and implementation. We have a couple more layers in there, which I just showed. The page object pattern also focuses quite strongly on the page, whereas we focus on a functional context, which might be over more than one page or more than one dialog. Page object pattern uses a lot of assertions. We tend to use checks directly via the UI. And also, I feel that there is a stronger user focus doing things like this. The page object pattern can, at some places, still be quite from a technical perspective, and we try and really look at things from the user perspective of how a user who's going to work with the software is actually going to work with it. If you know Gojko Ajic, he also talks about 3 layers, which goes along the same line, and also here we have a couple more layers. So we're not reinventing the wheel. It's important to know that, but it's taking it and adapting it and trying it out in various different contexts to see what works. Okay, let's have a look at a bad example. Bad examples are always good. So this is a lovely example of a bad example because there is a lot wrong with it. We can see that the idea is that it wants to delete the customer, but then everything gets very, very technical very, very quickly. So this is the classic, I have a test case. I'm assuming it's a test case right now. And then I'm just calling things pretty much straight from a very, very technical level, possibly directly from my tool API. So there's absolutely no abstraction. As soon as I need to find my customer again, I'm going to end up with redundant object location, which means that if anything changes there, then I'm going to have to do that at multiple places. We've got technical operations at the highest level, which means that if you do have an interested customer or test manager that wants to look into these things, they're probably going to say, I don't really know what this is. And the data is all hard-coded as well. So this is an excellent example of a very bad example, and it is not far away from things I've seen in the wild. This isn't just an example that we've created just because this is close to reality from things that we have seen. Let's have a look at what something like that could look like in a good example. So here we can see we have a test case that says create customer. We have some kind of data object, which I'll talk about later. And then we have these three things that I had in my test case in the abstract example I showed you before. So I'm obviously in the context customer administration. I check that the customer doesn't exist. I create the customer, and then I check that the customer does exist. And this is good for multiple reasons. We have very clear levels. This is very understandable for various people. I'm going to talk about data objects in just a second, and we have a pattern that we use. We call it VAV, which means verify, act, verify. And I've got an example of that in just a second. This is an example of a good layer at the top level just below the test case. Let's have a look at the lower layers of that. So that create customer, you can see on the lower level of the slide, that's the public workflow. That contains all of the things that we need to do to actually create a customer. We open the menu, we open the submenu, we fill out the customer form, we click save, and then we go back to the main menu. And that fill out customer form you can see above in the internal workflow, and that consists of the functional atomic actions to set the name, the surname, the street, the postcode, the city. You can see already here that these are prepared to be able to use the data objects later, so that we're not giving in data at multiple different places, but that every keyword is set up so that it can receive a data object. When it gets to the even lower levels, this is where it actually starts to make a difference what tool you're using. So the example I've got on the top of the page right now is one example of how something could be selected from a table in Selenium. To be 100% honest with you, what happens here in the area that's surrounded in purple, I don't need to understand that. I didn't write it. I understand exactly what this does. If I want to select something from a table in my UI, then this is what I use. I can see that I need to say which table and I can say which value. And the rest, that's fine by me. So that at the technical level, that can be very, very different. If you look at, for example, I've got now on the screen a very similar action from the Jubiler API. You can see that the Jubiler API offers something that's very close to that. But still, I don't need to go into too many details because I still have the select value from table that lets me, in this case, it's slightly different. It says, okay, from which row and which string value do I want to select something? So at the lower level, yes, our tests are likely to look very, very different depending on what tool. But at the higher levels, the higher we get, the further away it is from the technical side and a lot closer to the functional side that the user and that the testers are going to be very interested in. So I mentioned that we have the pattern VAV, verify, act, verify, because otherwise you just don't know if your test has succeeded or not. It is so easy, and this is one of the biggest anti-patterns that we see when we go to people to consult, that they maybe write a test that looks like this, create a customer. Unfortunately, if this test passes, it could still be very much the case that create customer doesn't actually work. If the customer already existed, then I might have a positive test that actually wouldn't have been positive. And if I don't check that the customer is then created afterwards, I mean, the classic example is I click on save. That's the last step in my test. I don't do anything else. And as I click on save, an error dialog is shown to say that the customer couldn't be saved. So if I don't go and try and look for that customer, I will never find that error dialog in my automated check. And I may not ever find that even if the customer does get created, that data was missing or that it went wrong. So this is why we have this structure of first checking that the thing isn't there or is there if we want to delete it, then doing the thing and then checking again. So we verify, we act, and we verify. And this is a good pattern that is usable in quite a lot of places for actions via the UI. I mentioned data objects before as well. And you saw a few examples of how we prepare for that in the actions. So the key and the column in my data table can be encapsulated there, such that if I have something like my customer that I just had, I don't need to redundantly enter data, which gets harder to read. It's easier to make mistakes. If I change one thing, then I might forget to change another. Instead, I just have a table that is central and it's used for my context that has different types of customer in it. If we're thinking of insurance, then that might be the case that I have somebody who is under 18, somebody who is between 18 and 25, somebody who is 25 to 65, and someone who is 65 and above. So I have my classic boundaries and my test cases for that, my test data. And then I just call those data objects within my test so that I don't have the redundancy. And of course, it becomes a lot easier to read. If anything changes, then it changes centrally. One last pattern that I want to go into, there are quite a lot of other things in terms of setting up test data and how to deal with these things, but time constraints mean that I'm just going to go into this last one. This is a pretty nifty one. If we have this, our internal workflow for fill out customer form, and it has the name, the surname, the street, the postcode, and the city, it might be the case that I sometimes want to fill out the form with everything. It might also be the case that I want to fill out the form just with the mandatory options, and that might mean that I only set the name. Now, of course, I don't want to write separate keywords for every single possible combination I would have of that. So if we look at what those individual things consist of, so the set name is actually a replace text, and if we then look at the bottom, you can see that the technical keyword for replace text does something kind of cool, which means that if null is entered as a value, then the step will be skipped. So I'll be able to use the same keyword to be able to fill in all of the fields, to fill in some of them, depending on what I'm used. And obviously that plays really well together with my data objects that I can just plug into my tests and have various different types of customer, types of data, and I don't need to have multiple redundantly written modules that will fill in my forms. So the form pattern is kind of useful. Okay, so I've shown you some examples, and I do have a very important disclaimer afterwards, which is that this works all of the time like perfect unicorn rainbow poop. Obviously, what I'm trying to show you is that things that have proved good for us in the context we've used them. They've saved us a lot of time. They've saved us a lot of hair pulling out. We hope that we're showing customers and developers and other people that UI testing is something that they can trust and that can really help them. Of course, that doesn't mean that there will be contexts where it doesn't work in the ways that I've shown. We haven't found them yet. That doesn't mean that they don't exist. So that's post-example disclaimer 1. The last thing that I want to leave you with before a short summary is that I know that there are people listening who are saying, these are patterns that we already know from software development. And my answer to that is that I will stop talking about this when people actually start using them. So we need to train developers to use these patterns when they're writing UI tests and to really write UI level tests at the correct level. And we also need to train testers to use them so that they're using the right kind of abstraction levels, that they're talking about separation of concerns. Those are things that we are training our testers in. Even testers that haven't used Java previously are working with examples like the ones that I've shown. This is all trainable, we just have to do it. And knowing that those things exist already isn't the same as actually using them and using them well in projects. So that's something that we really need to do as an industry. That is my plea to everybody, to work on this and to train people and to do it properly, because otherwise the bad reputation is going to continue, and that makes me very sad. Okay, things to take away. I hope that I've convinced you that you really do not have to hate your UI tests. You just have to do them right, and you have to use them for the right things. You don't necessarily have to reinvent the wheel. But it is expandable and it is extendable, and it should be reevaluated for new contexts. That's one thing that we do quite frequently internally. If we get new applications or new things, we evaluate, hey, do these things still work? So far they have done, but we keep checking. And use the patterns that I've discussed to get developers and testers of all flavors. So whether they're very technical, whether they're not quite as technical, whether they've been developing for years and years and years, or whether they're just fresh, use these things so that we have a common way of looking at tests and a common way of structuring tests, which will improve the quality of the tests and then, of course, the quality of the software, and people will stop hating UI automation.
Thank you, Alex. If you have questions, you can contact Alex via Twitter or on her homepage. Next week, Alexander Schwartz is going to talk about 4 agile testing principles, which may help you to better your decision-making process in an agile testing strategy. And now I have to say thank you, Alex, for joining me. It was fun.
It was great to be here.
And I hope to see you soon in Potsdam.
Yep. Bye-bye.
Bye-bye.